Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shah Ikmal bin Junaidi. My metric number is 222846.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fitri bin Suhaimi. My metric number is 222562.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Hilman Hasif bin Zafirus from section 880. My metric number is 223106. Basically today I am going to present you guys about centripetal force.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farhan Najmi. Alhamdulillah. Metric number is 225666.
In Chapter 4, resolving vectors into components for displacement, velocity, and acceleration is important. Position vector will change if the point is moving. We can get displacement vector from delta r. Delta r equal to r final minus r initial. Velocity vector represent the rate of change of the position and object. We can get average velocity and instantaneous velocity from delta r over delta t. Acceleration vector is defined as the rate when velocity change. Here, we can get the average and instantaneous acceleration from delta v over delta t. Now, let's move on with the sample question. Consider the following controls in an automatic in motion: gas pedal, brake, and steering wheel. What are the controls in this list can cause an acceleration of the car? A. All three controls. B. Gas pedal on brake. C. Only the brake. D. Only the gas pedal. E. Only the steering wheel. The answer is D. Only the gas pedal, because the pushing of gas pedal increasing the car's velocity. Okay, next question. A particle moves in the xy plane starting from the origin at t equal to 0 with an initial velocity having an x component 20 meter per second and a y component of negative 15 meter per second. The particle experiences an acceleration in the x direction given by ax equal to 4 meter per second square. The first question is determine the total velocity vector at any later time. The first thing we need to do is point out the important information. Next, we must use this equation for the velocity vector. Now we need to begin the mathematical analysis that we said. Just use the information we already point out and use the equation I just shown. And substitute numerical values in metric units using calculator. Don't forget the bracket. Now the answer we got is velocity final equal to 20 plus 40 I minus 15j.
In this subtopic, I will talk about projectile motion. What is projectile motion? Projectile motion exhibited by an object launched into the air near the Earth's surface and experiencing free fall. Now, I'm gonna share a tips about projectile motion. Projectile motion is a combination of two analysis models, which is particle under constant velocity model in the x direction to particle under constant acceleration model in the vertical direction with a constant downward acceleration of magnitude g equal to 9.8. Okay, for now I want to show you 4 models about projectile motion. First is when you throw down a ball into downwards, so you get a ball will fall. Second is when you throw up a ball and it will come down. Third model is when you roll down a ball and it will fall. Fourth model is when a fireman shooting water with hose into a building. I want to explain you about a sample question. 18. A fireman with a distance equal to 50 meters away from a burning building directs a stream of water from a ground level fire hose at an angle of 0 equal to 30 degree above the horizontal as shown in figure P3.18. If the speed of the stream as it leaves the hose is velocity initial equal to 40 meter per second, at what height will the stream of water strike the building? So, as we can see at figure P3.18, we know that the distance is 50 meter and the angle is 30 degree and a velocity of water is 40 meter per second. So what we can do? Okay, actually we need to find a time first. So how we get the time, which is we get from delta x equal to Vx initial time plus 1 over 2 at squared. So if we solve this, we will substitute the number and we get the time is 1.44 second. After we get the time, which is 1.44 second, we need to find delta y. Delta y is height. Okay, we use the formula is delta y equal to Vy initial plus 1 over 2 gt squared. Okay, we substitute the number, time we substitute with 1.44 second and we get the height is 18.64 meter.
Centripetal acceleration, the formula is A2 equal to V to the power of 2 divided by R. The radius of the spring circle. Centripetal acceleration, the concept is this: if A increases as Vt increases, and by that R decreases. The next section, centripetal forces, which means the force that pulls objects towards the axis of rotation during circular motion. As we see in the slide, the centripetal forces formula is Fc equal to mvt to the power of 2 divided by R. This is derived from AC, which is V to the power of 2 divided by R into the F and A, the root of first formula. What centripetal force concept the force that must be applied to produce the circular. In the real life, we can see the centripetal force in gravitational field and tension of this field. So to the question, what is the magnitude of the centripetal force that must be applied in order for a 0.5 kg ball on a 2 meter swing to spin with uniform circular motion at 5 meter per second? So we know that the mass is 0.5 and the R 2 meter. By the equation set, uniform circular motion at 5 meter per second. That means uniform circular motion is V. So V times 2, V to the power of 2, and multiplied to the mass of the ball 0.5 and divided to 2 meters here. This is R. The equivalent is R. So we calculate it and we can get the answer Fc equal to 6.3 meter.
So for this part, the given data is the radius of the circle is 0.30 meter and the height of the plane above the ground is 1.2 meter. And the ball lands 2.0 meter away from the point directly beneath the ball's location. So the first part is we're gonna use the formula to find the horizontal range of the ball, which is R equals to Vt, you see here, and the formula for time of flight is equals to T equals to square root 2h over g. Okay, for the second part, we're gonna substitute the square root 2h over g, which is equals to t, for t in equation r equals to vt here. After we substitute it, we're gonna get r equals to v square root 2h over g, and then we're gonna substitute the number that was given in the question below. So r so 1.20 meter for h, 2.0 meter for r, and 9.81 meter per second squared for g, to find v. Sure. And then after we calculate it, we're gonna get the v velocity of the ball, 4.04 meter per second. After we get the velocity of the ball, we're gonna use other formula, which is a equals to v squared over r, and then we substitute the v and the r, and we're gonna get a equals to 4.04 meter per second squared over 0.3 meter. After we calculate, and we're gonna get the acceleration or the radial acceleration of the ball in the circle. So the 0.3 meter here is the radius of the circle, which given data. And after that we calculate, we're gonna get radial acceleration equals to 54.4 meter per second squared. So therefore the radial acceleration of the ball during the circular motion is 54.4 meter per second squared. That's all. Thank you.